there are simple rules for finding derivatives. Now you recall previously, if y equals x squared, we calculated y prime limit as delta x approaches 0 of what? Change in x between x values x and x plus delta x, which is x plus delta x quantity squared minus x squared divided by delta x. This is change in x, this is delta x, between 2 points of the y equals x squared graph. If we let delta x approach 0, then this point approaches the y equals, or the x value point, and the limit, as we've seen, if we expand this, simplify, divide, take the limit, is 2x, meaning that the slope of the y equals x squared graph at the point x squared is 2x. So if we know the x coordinate of a point on the graph, we can find the slope just by doubling that x coordinate. Now, if y equals x cubed, we could do the same thing. We could do this limit, except of course now this quantity would be cubed, this quantity would be cubed. So we'd have to expand this cube, keep using the distributive law, keep multiplying, doesn't take too long, and simplify and take the limit. And once again, we would get a limit, but in this case, the limit would not be 2x, it would be 3x squared, because of course we'd be cubing this, this would be an x cubed, things would come out different, and the derivative, the limit that we would get would be 3x squared. Now, I could ask you to do this for any power. I could ask you to do it for 4th power, 5th power, I could ask you to do it for the 100th power. You'd tell me to go jump in a lake, or you just wouldn't do it, you know, if you wanted to be polite about it. But you know, that would be ridiculous. I wouldn't ask you to do that. I'd ask you to do it for 3rd or 4th power, though. Probably wouldn't ask you to do it for 5th power. If you can do it for the 4th power, you can do it for the 5th. Well, if you do that, if I had asked you to do that, and it really wouldn't be a bad idea for you to do it. It doesn't take too long, but I'm not going to require it. If we do this for y equals x squared, x cubed, x to the 4th, and x to the 5th, we're going to get derivatives. Y prime equals 2x for x, y equals x squared, y equals x cubed, as I've said here. By the same process, would give us 3x squared. X to the 4th, we would get 4x cubed, and for x to the 5th, we would get 5x to the 4th. So, how is the exponent related to what you see over here? In every case, there's a clear relationship between the exponent of your y function and the exponent and coefficient of your y prime function. Well, people saw this rather quickly. So, well, okay, this exponent is going to be 1 less, and the number out in front is going to be the exponent. So, that seems to be true. Exponent is 4, there's a 4 out in front, and 3 is 1 less than 4. Exponent is 3, there's a 3 out in front, and your exponent is 2. If you work out a few of these using the limits, you can actually see where all this comes from, but it's not necessary to do so in order to be able to apply the rules, and the rules are somewhat easier than the process of deriving them, although this rule is not too difficult. Your book has a derivation. We've done this, and from what we've done, you should be able to understand the book's derivation. But I'm not going to ask you to derive this on a test or anything. Okay, so my question then was, okay, if y equals x to the n, then what's y prime going to be? Well, people got a little funny about, not funny, I mean, people appeared a little bit blank on this, although there were some pretty good attempts. But what's our rule? The exponent goes out in front. So the exponent is n, we put an n out in front. And then the power is 1 less than the exponent. What's 1 less than n? Well, n minus 1. So we have y prime equals n times x to the n minus 1. And that's our formula. And that formula is going to apply to any function of the form y equals x to the n. Now, the derivative of y of x can be written as in any of a number of ways. Okay, one way that we've used is just as y prime. A little more specific, y prime of x. This is function notation, not y prime times x, y prime as a function of x. And if it's important to specify our variable to remind ourselves, we would want to use the function notation with the x in here. Another way is dy dx, and that makes perfect sense if you understand that this expression that we used here to derive the formula is, well, remember, this was the rise of the graph, this is the run. The rise is the change in y, the run is the change in x. Well, dy is a lot like delta y, like a change in y. Dx is a lot like delta x, change in x. It's like we got a change in y divided by change in x, except that now we've taken the limit as delta x approaches 0 to see how these two quantities ultimately change with respect to one another. And another way we could write it is just d dx of y of x. Okay, we'll kind of use this a little bit. And the dy dx or the d dx of y of x notation is pretty appropriate at this stage, and that's what your book uses. I've used a lot of y primes simply because when I type things out, that's much easier and less confusing than the dy dx notation. But they all mean the same thing. So now my question is, okay, if y equals x to the 7th, what's dy dx? Well, if y equals x to the 7th, then we do have a y equals x to the n with n equals 7. So that y prime is going to be nx to the n minus 1. N is 7. We're going to have 7x to the 7 minus 1, or 7x to the 6th. And that's the way it's written out here. So okay. So that takes care of the y equals x to the 7th example, and that one's pretty straightforward. Now, we could also write our rule as derivative with respect to x of x to the n equals nx to the n minus 1. That's the same thing as writing y prime equals nx to the n minus 1, except we don't even mention y or y prime. We just say the derivative with respect to x of x to the n is nx to the n minus 1. So we could say, in relation to this problem, that the derivative with respect to x of x to the 7th is 7x to the 7 minus 1, just the n equals 7 version of this definition. And that's 7x to the 6th. So just another way of notating the same thing. So all this is valid. You can make your choice about the way you notate it, unless you're asked to notate it in some specific way.